This is part 2 of the 5-part series on the net ionic equation. In this video, we're going to write total and net ionic equation when the reactants and the products are given, but not the physical states. Let's take a look at this question. We have CuOH2 plus HBr giving us CuBr2 and H2O. Since we don't have the physical states for every term, we're going to have to refer to the solubility rules to identify the states. That's the first step that we need to do. So if you need a refresher on how to determine the solubility of compounds, I'll link the video here. So it looks like we have solid for CuOH2, aqueous for HBr and CuBr2, and liquid for H2O. So we move on to the second step. We need to make sure that the equation is balanced. Again, if you need a refresher on balancing equation, I'll link a video here. So we need to place 2 in front of HBr and 2 in front of H2O. So now we have equal number of atoms on both sides of the equation. So our equation is now balanced. So we can move on to the third step. We need to ionize the terms. So that means we need to ionize the aqueous terms, breaking up the terms so that it will become ions. Before we go on, it's important to note that we only do that for aqueous terms. We don't do that for solid, liquid, or gas. So if you need a refresher on how to split ionic compounds into ions, I'll link the video here as well. So let's start with the first term, CuOH2. It's a solid, so we're going to leave it be. So we're just going to write it out as CuOH2. Next is HBr. Since it's an aqueous, that's going to split up into H plus and Br minus. And because we have 2 in front of HBr, we're going to have to make sure that we have that 2 in front of 2H plus and 2 Br minus. Next, CuBr2 aqueous. That will split into Cu2 plus and Br minus. Since there's a 2 for Br, we need to place that 2 in front of Br minus. Don't write it out as Br2 minus, as it doesn't exist. In fact, that's actually a common mistake that a lot of people make. So please make sure that when you write that 2, it's placed in front of the bromide ion. So it's 2Br minus, not Br2 minus. Now moving on to the final term, it's 2H2O. Since it's liquid, we don't ionize liquid, we're just going to write it out as is. At this point, what we have written is the total ionic equation. So now that we're done with step 3, let's go on and move on to step 4. So we need to cancel out spectator ions, which are the ions that exist on both sides of the equation. So in this case, we have 2Br minus on both sides of the equation. So we're going to cancel them out. Now we'll rewrite the equation, and then that will give us CuOH2 solid plus 2H plus aqueous, giving us Cu2 plus aqueous plus 2H2O liquid. That's the net ionic equation. So to make sure that we don't make any mistake, let's double check our work. So the number of atoms and charges must be the same on both sides. So let's check real quick. We have 1 Cu on both sides, 2 oxygen, and 4 hydrogens. As for the charge, we have a total of plus 2 on the left and plus 2 on the right. That means both the atoms and the charges are equal on both sides, meaning we have written the correct net ionic equation. So there we have it. We managed to write the total and net ionic equations in 4 steps. To recap, when the equation is given without the physical states, we'll need to first use the solubility rules to identify the physical states for every term. And then we make sure that the equation is balanced. After that, we have to split the aqueous terms. Remember not to touch the solid, liquid, or the gas terms. And then that will give us the total ionic equation. And then to write the net ionic equation, what we have to do is cancel out the spectator ions and then rewrite the equation. If you're looking for a more challenging problem on writing net ionic equation, do keep an eye out on the other 3 videos in this series. They're coming soon. I hope the video was helpful somehow. Do subscribe, and thanks for watching.